So, as I mentioned I think at the beginning of this video, I'm going to use this style of 18650 holders, and I have a sort of box of these that I bought off eBay some time ago, and you can buy them in the hundreds. And I've got single bricks, 2 bricks and 3 bricks together, and I mean you can get these in all sorts of configurations, going up from this and 4 and then in grids, but these ones I'm going to use at the moment because, as I said, I want to end up with a 3x3 grid by 2 deep, and these just simply connect together like a Lego, well, not like a Lego brick, but in a similar sort of manner to a Lego brick, in that they just have 2 slots, there's a male and a female, and they simply go together. So to make up some 3x3 grids, very simply, as I've got here, in fact I've used what I had in terms of 3 together. Very simply, you end up with a 9-way grid, and this one I've had to use 2, 2, 2, 2 and a single one in this bottom right hand corner. I didn't have enough 3s, there's another one I've made with a 3, and finally, yes, another one which 2, 2, 2, 2 here, and then there's a single one in here. So effectively what we will have is, a long battery, square in profile, 9 cells in here, 9 cells in here. Okay, so let's put that together then. Just before we put some batteries into a pack, let's do some back of the envelope calculations using the back of an envelope, where all calculations should be done. So as I said, the battery that I removed these cells from, it was nominally rated at 11.1 volts, and it said 60 watt hours. We do a quick calculation here, so we say that, oh, not very quick if I make it go away, 60 divided by 11.1, so that's 5.40, and I'm going to say that's capital A amp hours. So when I was taking the batteries out, I think you could see that they were in what we call a 3S2P. So that's 3 cells were in series, and each pair of cells was in parallel. So the 3 cells at 3.7 volts, 3.7 multiplied by 3 gives you your 11.1 volts. So we can then divide this storage capacity of each cell in amp hours by 2 to find out. So 5.4 divided by 2 is 2.7 amp hours for each cell, and that equates to this particular cell here is a Samsung cell, and indeed, if I hold it the right way up, is nominally rated at 2.8 amp hours. So yeah, 2.7, 2.8, that's near enough for me. Now I'm proposing to use a different profile of batteries. I'm going for 6S3P. So what's that going to give me? So let's look at the voltage first, and we'll just take the nominal voltage. So we'll go 3.7 multiplied by 6. So I'm going to nominal voltage of 22.2. When the batteries are full, let's just have a look at that. 4.2 will be their full voltage, times by 6, so that's 25.2 volts. And when they're empty, I would say empty is typically 3.3 volts, multiplied by 6 again, so we've got 19.8. So in charging and discharging, we're going to cycle from one and back to the other. So we will see a full battery being 25.2 volts and an empty battery being 19.8. Great. Low fly. Well, I am in Australia, aren't I? Okay, so now just doing a little bit more thinking about what power we're going to use, how long is the torch going to last. So I'm proposing to use a 100 watt LED. So you can not unreasonably say that it's going to draw 100 watts at its full brightness, but there's going to be an inefficiency if I'm going to be using a power supply such as this. Typically I can't expect more than, say, 75% efficiency. So again, roughly adding another 25% on there, I'm going to use 125 watts if it's at full brightness. And looking at the batteries that I've got, so they're around about this, what did I say, 2.5 down to 2.1. So let's call them 2.2 amp hours each. But I've got 3 in parallel, so I'd say that was going to be 6.6 amp hours. So at a nominal voltage of 22.2 multiplied by 6.6, I'm going to be looking at a battery which is now 146 watt hours. Okay, we're going to be using 125 watts. So just a rough calculations is that it could run for 1 hour plus a little bit, possibly. We'll see. Another sort of interesting or necessary calculation, we just have to make sure that running at 125 watts, that we're not going to pull too much current out of these batteries, particularly when they're in their depleted state just before they should be sort of switched off. So I'm going to run out of envelope here, so I'm going to have to move on to the front of envelope calculations. So again, using this 125 watts as a bit of a guide, if I use, power equals current times voltage. Worst case voltage I said was 19.8. So if I divide 125 watts divided by 19.8, so the current coming out of the batteries will be 6.3 amps when just before they cut out. Now 6.3 amps, I've got 3 in parallel, so I'm going to divide that number by 3, so I'm looking at 2.1 amps per cell. So look, that's okay. It's getting a little bit close to the C rating. I mean, these batteries, as I said, when they're brand new, 2,800 milliamp hours. So their one C rating would be 2.8 amps. They are not new batteries, so I want to treat them a little bit more gently, and so yeah, 2.1 amps per cell is probably as much as I want to reasonably go on them. But yeah, hey, everything seems to work out. A little bit of margin of error, hopefully. I will do some checking on how much power is drawn when the lamp is on full, when the LED is on full brightness. And in point of fact, you know, I mean, it'd be fun to run this at 100 watts, but practicality says that from a brightness point of view, I'll probably be turning down the wick quite a lot on during its usage, so I should get longer use, and the amount of ampage that I'm drawing should be much below this 2.1 amps per cell. Anyway, let's, as I say, get back to building the pack itself. So this is the arrangement I'm going to use. I've sorted them out into the 6 series sets that I want to use. I used a website called repacker.com, quickly just plugging in these values with a comma separating them. Told them that I wanted to make a 6S 3P pack, and it told me which best arrangement of cells to use, so that we end up with each group of 3 cells being roughly the same capacity, Now I haven't got too many cells within each sort of parallel range, so there is a bit of divergence from one pack to the other, and just looking at the numbers on the screen, yeah, up to, I think the worst case is 60 milliamps different, 67 in fact to be accurate, 67 milliamps difference, milliamp hours that is, difference between the top pack and the average. Anyway, just a final check, because these batteries have been in storage for quite a while, and before I put them in storage I made sure that they weren't fully charged, so I put them back on the chargers to bring the voltage or the storage down, and they're sitting around about 4.1, or within a okay, that's a little bit low, 600ths of a volt low. Most of these, sorry, getting in the way of my own meter here, are within 1/100th of a volt, which also gives me a bit of heart to say, yeah, that's probably means the batteries are still in reasonably good condition. Okay, so adding these into the blocks, very simply they push in place. Now, I've made a mistake already, because I need to change the polarity from one end to the other, and then we'll go so positive, negative, and then positive for that pack, and then applying the top piece. Just got one battery there not playing. Okay, that's one pack. Bring in the other two very quickly. Now, just thinking how these two packs are going to go together. So if this is the positive end of the battery, then we'll be coming across, down to here. That is negative, then we'll want to go to positive. So yeah, I think I'm okay just going positive, negative, positive. Doing the same for that battery pack. Okay, so hopefully you're now getting the picture of how the pack will be going together. I've just come across to my other bench ready for putting the cells together, and I forgot, I want to apply, just finishing them off actually now, these fibre washers on top, on the positive end of the battery. It just provides that little bit extra amount of protection from shorting. I'll just demonstrate or rather point something out to you. In terms of a cell, clearly this is the positive end, this is the negative end. If I was to remove this wrapper, which is just a very fine piece of mylar shrink wrapped onto the cell, then there's the negative end of the battery forms all of the outside wall right up to the top here. And so it's quite easy, if this becomes damaged, this mylar becomes damaged across here, to actually short the battery positive to the negative. So if we take what I'm going to do now, and we're going to connect all three positives together and then connect it across to the negative, if at this particular location the mylar were to rub away or wear through, then yeah, I'm going to have a dead short on that particular cell. So not a pretty event. So you can get these on the internet, probably from the same vendor that you can get the 18650 holders. I recommend you use them, just a few cents each. Okay, we have the two packs ready to go. I'm going to be welding my packs together, and I'm going to be using this nickel strip. This is pure nickel strip, it's not steel with a nickel plating, it has been tested. I also have some pure nickel strip here, which I got from Sunstone Engineering in the US. Quite expensive. This is just a single strip, and I'll be using that to go from one pack to the other, and to go from one pack to the other in the center, and also probably maybe using some of it on some of the terminals. I'm not too sure yet. Now, I like this strip because it's going to be applied in this sort of a manner, and so I'll be connecting the positives to the negatives. I'm going to be welding this strip in place using my home weld welder. Now, if you don't have a welder, which is probably the case, then you can solder batteries together and just solder wire directly onto the terminal and come across from one to the other. There are plenty of other people who've done soldering. I prefer not to use it. It's, you know, any heat going into the battery has the potential to damage its life. Lots of proponents for and against. I'm not going to get into that argument. I'm just going to use the equipment that I've got. Okay, so just before I do a weld on the battery that I want to make, I'm going to do a test weld just to make sure everything is okay. It's been quite a while since I've actually used this equipment. So just this is a dead battery, dead 18650. We'll pop the two electrodes on top here, press down, but not very hard, just with maybe 100 grams. And what we have hopefully are two welds. You can see the 2 points there hopefully, and yeah, and that's actually torn the metal in that location, so that's going to be good enough. Okay, I've pre-prepared some nickel strip pieces, and we'll start the welding. To get this centralized. Before I do the first welds in the center. 1, 2, 3. I'm going to do a second set. These won't be as good as the first, but just as an insurance policy. The beeping that you can hear is the welding machine just charging back up again. It just takes a few seconds. Last two there. So then if we've connected these two batteries at this end, then we want to connect these two batteries at this end. So I'm going to put a metal strip on like so. I just paused the video there just to get my head straight on what I'm doing. What I'm going to do actually is I'm going to make this end here the output end on the positive side. So I'm going to mark this up positive for the moment. So it comes positive to negative, positive to negative, positive to negative, and then I want to run to the positive of this pack. So I'll be using this strip to connect those two, but I'm not going to do that at the moment. I'll do that later. So if I'm coming down through here to negative, and I'm going to want to run the first duplicate across from negative to positive on this side. So yeah, again, coming positive through here, I want to do this connection here. So this is going to end up being the negative, and so I need to cross connect these from positive to negative. Pack number 1. Volts. Pack number 2. Connecting across the right ones. 12 volts. Okay. So again, realigning these as I was looking to have them. Create a little bit of space there. Indeed, I've got some tails here which are too close to my liking, so I think I'm going to have to trim those back a bit. I'm going to bring these two packs together, but before I do that I'm going to find some material to create some insulation, certainly between these sets here. I don't want any shorting out at this location. I can start off, I think, by maybe applying some of these center dots here just over the batteries. That will provide a little bit of protection, and find some plastic to finish it off. So I've just popped a bit of gaffer tape around the corner there, just to protect that corner. Now I'm going to put a piece on across the whole of the top. You can fold those up quite safely. And we can do another check of the battery at this stage. Now we can see the positive and negative. 24.6 volts, that's excellent. Now I can start adding the balance wire. Now I'm going to balance charge these, and also there will be a checker on permanently connected to this so that the batteries can't go too far out of alignment in terms of voltage. And the way that we attach these leads is black goes to the negative side, and then successively moving along to the red, white, yellow and so on will come back through the pack all the way through to the positive side. So we have negative 1, 2, 3, 4, 5, 6 for each of the 6 cells in the series. So I was forgetting for a second there that I have to actually connect these batteries at the negative end and the positive end actually together, so we do this with just an L-shaped strip here. I'm going to take the negative connection down to the other end of the battery so that when I do the connections then they're a similar distance from each other. So the battery pack is coming together quite nicely now. I've managed to fit the balance wires all the way from the negative all the way through to the positive, which is on the blue wire. And I had to extend these wires ever so slightly, maybe by the length of the battery pack. I wanted to ensure that when the battery is mounted inside the torch that I'm still able to connect it up to the charger and the balancing port on the charger. So yeah, just making sure there's maybe 100 mils free movement there. I'll get those tied up and tightened down. So that's pretty much the battery pack completed there. I'm just going to fit the positive and negative connections on here, which will be used actually for the charging port and for also the powering of the power supply for the LED. So nearly finished. Balance wires are all on there. I've tried to neaten those up as tidily as I possibly can. I've actually extended some of the colours just so that the lead has got enough length on it for charging. This is the charging side. I probably need to put a couple of cable ties on here. On this end of the battery, as it will sort of go into the drain pipes, I've got two tails here, much longer than they need to be, but I've just got those taped off for the moment. So in terms of charging, we're just simply connecting up like so for the charging current and like so for the balance wires. Now, I've done the charging already, so I'm not going to go through that. It's one of these cheap copy chargers, but it seems to do the charging okay. One thing I have noticed though, just on completion, and it was a balance charge that I went through, so it took a little while to bring those batteries back up. I've got these little checkers here, and I've seen these on the internet. A number of people have been using them, and it's a low voltage alarm that I propose to use. And just making sure I've got the negative the right way around, so that's that way. So just plugging in like so, and it shows you the battery voltages. All that's clearly not right. So yeah, there's some weird features here. So obviously I only detected one battery as I've connected it in. Let me try again. So yeah, 6C5, it's picked them up. 24 volts, all of them. 4 volts for the first, 4.05 for the second, 4.05 for the third, 4.04 for the fifth, and 3.98 for the sixth. 3.84 for the last one, rather. So yeah, I was a bit confused, you know, particularly those two last voltages, why they're so low. And so I've gone and checked with a digital multimeter. If I can try and bring that in here now. And basically what I'm finding is that, not surprisingly I suppose, that these units are not that accurate. Let's see if we can get this set up so you can see the voltage. First of all, I'm going to do the total voltage. So 24.3, this unit's displaying 24.0, so about 0.3 of a volt different there. And then if I go across each individual so it's 4.06, 4.06 for the next one, 4.05, 4.04, Sorry, it's a little bit awkward, is this? Not too sure whether I missed one there, but that's 4.06, 4.05. So indeed they're all around the 4.05, 4.06. There's certainly none down at, what's it saying, 399 here, 385. So there's a good 0.2 volt difference there in this. Have I got a bodgy unit? Possibly, but I've got 5 of them, and I tested another one, and 24.1, so again a couple of tenths down on the voltage. Number 4 is 404, 5 is 406, and the last one is 391. So again the last one for some reason showing a lower voltage. Anyway, so can't really rely 100% on this, really only to the nearest tenth or possibly 2/10 of a volt, unfortunately. Anyway, that's as far as I'm going to take the battery at the moment. At this point I would either sort of really give this a good reel up with gaffer tape, but I have actually ordered some heat shrink tubing, which I'm hoping is going to be a neater solution for this. That hasn't come through in the post yet, so I'm just going to leave it like this for the moment. I've got plenty of other things to do on the build. Anyway, I think that's enough for this video. That, as I say, is the battery 95% complete. Wait to next week and we'll see what we do in terms of the body of the torch, and probably look at the LED itself and getting that powered off this control board. Thanks anyway, see you later.